problem 15.3.29 and have just the first part of the question up here. It says that a hospital is developing a regression model to predict the hospital bill for a patient based off of three independent variables. One is the patient's age, the length of their stay in the hospital, and then the number of days in intensive care. So this is another longer problem within the homework, and so I'm not going to touch on every single piece of it, but just want to show a couple of things. One being how we can solve for the regression equation in both the data analysis Toolpak as well as XLStat. So let's do that first. And go to data analysis and regression. I'm going to choose our variables here. So cost or price of the bill is our dependent variable. We have our independent variables of age, length of stay, and intensive care days. And so in the problem, we're not given a confidence level or alpha, so we're just running this as the kind of the default of 95%. And that will be a factor in just a moment. So let's see what our output looks like here. So here we get just kind of the output that we're used to seeing. We've got pretty high F-stat, very, very low p-value. So this model is significant based on the data that we are working with. And you can see we've got pretty high R squared and adjusted R squared as well. So the model looks pretty good so far. These are our model coefficients, so this is what we would use to build the regression equation and run a specific scenario. So the question also asks for the confidence interval for the regression coefficients here. And confidence intervals are over here. You see that Excel, the data analysis Toolpak, has them basically twice. So it has the lower 95% and upper 95% because that's the confidence level, confidence interval that we chose. And it has them twice here. So we've got a lower and upper 95% printed twice on the table. So the reason that is because it's going to always show us in the data analysis Toolpak results, it's always going to show us a 95% confidence. And then if we choose a different confidence level, then that one will be here on the right-hand side. So in this particular problem, your problem will vary. The one that I'm using this data off of asked for in part B a 90% confidence interval. So if I were to go back into the data analysis Toolpak, first of all, I could delete this all if I wanted to because my coefficients are going to be the same. Everything else is going to be the same. The only thing that's going to be different is the bounds for the 90% for the new confidence range that I'm going to run. So for confidence level here, I'll just choose 90, and output I'll just put it right below. So you can see here that the data is the same. So we've got the same R squared, adjusted R squared. We've got the same F-stat and p-value as well. And just scrolling up here, so we have the same coefficients. And t-stats, p-values, everything is the same in the table. See the big difference, like I said before, is that we still have a 95% interval here. That's kind of by default that the data analysis output will generate, but we specifically asked for 90% confidence level. So this is what we would interpret in our problem, and typically in this question asks for the ICU interval. So this is what the data that we would use to interpret that part of the question. And if we were to run this in XLStat instead, variables again, 50 observations, quantitative, independent. And we need to make sure we have the number of levels correct here. And notice that the confidence interval, just from working a previous problem, was already at 90. So if you're using it for the first time, it's probably set to 95. So here's where you want to make sure you select the interval of 90 instead of whatever else it may have been set for a previous problem. We have nothing for prediction. Go ahead and run this. When this is done processing, we will see everything looks here. So the lower and upper bounds given for the XLStat output will now be based off of 90%. So it does not also include a 95% by default like the data analysis Toolpak does. So we've got, for example, ICU, 277 lower bound, 4112 upper bound. Compare that to our data analysis values we got are the same. So for this particular problem, we were able to get all the output that we needed just from the data analysis Toolpak. But again, just wanted to show you this difference with the output that it shows for the application, because it is a little confusing to students why it always has duplicate values if we are running 95% confidence. But again, also how we could just get this information from XLStat as well.